Hey everybody, Chapter 5's lecture short is on the topic of heat transfer and heating foods. This is particularly important to food science because there are specific things that we can do whenever we're cooking or baking to make sure that our foods are browned appropriately or that have the right texture, or that when we're cooking meat, we can choose the correct cooking method to yield the most tender cut of meat. So just to get into this briefly, heating foods is important to us because it can make things a little bit more digestible, but also can destroy foodborne illnesses that can make us sick. And while we do heat foods, we are changing the molecular structure of those foods. So this can alter their taste, their texture, and their appearance. And because of that, we can make foods a little bit more palatable. We do have the chance of losing some vitamins and minerals in this case, but generally it's helpful to heat foods to make them safer for us. So there are two basic types of heating methods. Sorry, my Apple Watch went off. There's two main types of heating preparations. We have our moist heat preparation and our dry heat preparation. These are going to be used specifically for the foods that we are cooking. So we're going to make that decision, is this appropriate for moist or dry heat? Of course, with moist heat preparations, we are utilizing water or steam in some way to help cook those foods. With the moist heat preparations, we typically find a softer, more tender, especially with meat. But if we use more water, we have the chance of color, flavor compounds, and some water-soluble nutrients leaching out into that extra water. And so we have to kind of think about that sometimes. We're going to have a chapter or a lab on fruit and vegetable pigments especially, and we're going to see how we can lose some of those pigments which contain vitamins and minerals through some moist heat preparations. So I just wanted to call to your attention the difference between poaching, simmering, and boiling. Really, the difference is the temperature at which we heat this pot of water. I really like this visual because it shows us the difference looking at the bubbles, essentially, that are going to be created through heating these pots of water. So with poaching, we can see some bubbles like towards the bottom, but they're not going to rise, and they're definitely not going to break the surface of the water. With simmer, we are warmer. This water is being heated more significantly, and so we're going to have these larger bubbles start to rise up to the top of the surface, but they're not going to break the surface. And then finally we have a boil. This is typically known as a rolling boil. We see the heat is much higher here. The bubbles are much bigger and they are breaking the surface. And we'll have a lot more steam coming from the pot as well. So the big difference between poaching, simmering, and boiling is the temperature, of course, but what's happening with these bubbles. Then we have our dry heat preparations. We have some examples here, but we can typically reach higher temperatures with dry heat methods than whenever we are using moisture when cooking. So think about whenever you're like roasting something in the oven or grilling. So we have several types of heat transfer that are also discussed in the book. Here you see convection, radiation, conduction, induction, in a few different areas. I also like this visual because it gives us a better idea of sort of what's happening. So starting with radiation, which we see here with the fire. So this is a burner. This would be like a gas stove that's emitting or that's creating a fire to heat this pot. So radiation essentially it's not so much contact, but it's the particles that are the heat transfer from the fire towards another object. With conduction, we have particles that are actually touching each other, or objects that are touching each other to transfer that heat energy. With convection, you can see this in the pot or in the oven. Basically, convection is a current, okay? So we have water particles moving or heat particles moving in the air, and they're causing a current that's hitting the food, which is causing it to heat. The ovens in the lab are conventional ovens, so they don't go off of convection. But we have some convection ovens in the dish room. All right, and then finally we have induction. Induction is really neat. If you think about the front cooktop in the lab, it has a red, actually it might be black. I can't remember if it's a black or a red top, but it's the top, it's the cooktop in the middle of the front of the lab. That is an induction burner. I posted another video about how induction burners work, but essentially it's like an electromagnetic field that is created by some coils that are underneath the cooktop. And with induction, you typically need to use a special induction skillet or other cooking equipment that is made for the induction burner to work. Okay, and then finally we look at the ways that we measure heat. Typically we use Fahrenheit. Celsius is more so used in I see that in more like experiments, scientific, because Celsius is more widely used. And then Kelvin we aren't going to worry about in this class. So I want you to focus on Fahrenheit and Celsius, the water boiling point, the water freezing point, and then you can compare body temperature and absolute zero as well. If you have any questions, please feel free to email me, or you can schedule an appointment with me on Calendly through my link on Moodle.